The Big Bang of mathematics and the sums and differences of the cubes. My motto: plain honesty, simple truth, easy understanding, the joy of finding things out for yourself. Why the Big Bang? Simply because x cubed minus x cubed all divided by x minus x equals 0 divided by 0 does not equal 0 or 1, and definitely not infinity, as the mathematicians would have us believe, but instead is in this instance a precisely definable number for each and every x, and therefore gives us everything out of nothing. 1. Take a number x, say 21. Then 21 cubed minus 21 cubed, all divided by 21 minus 21, is equal to 1323, which is equal to 3 times 21 squared, and equals 3x squared always for all x. 2. Multiply x by 6 and divide by 2, then plus and minus 1. Hence, 6 times 21 all divided by 2 plus and minus 1 is equal to 62 and 64. 3. 1. We start by subtracting the smaller difference 62 from 1323 to give 1261, which after multiplying by 1, the difference of the two cube roots, delta, will equal the difference of the two roots cubed. We reduce the difference 62 by 2 at each step to give 1261 minus 60 is equal to 1201, which after multiplying by the difference 2 of the roots to give 2402, which is equal to 21 cubed minus 19 cubed. We continue the process for as far as we like. In Table 3.2, we carry out the same operations as for Table 3.1, but we start with the larger of the two differences from step 2, which was 64, and increase it by 2 at each step. 4. A correlation of the data from Tables 3.1 and 3.2 results in the equation y equals x squared plus 21x plus 21 squared is equal to x squared plus 21x plus 441 is equal to x1 cubed minus x2 cubed, all divided by x1 minus x2. 5. This slide shows the differences of the cubes resulting from tables 3.1 and 3.2 of slides 3 and 4, and which can be carried out indefinitely to plus and minus infinity. The procedure in an Excel spreadsheet is to produce two columns of integers, the first being a constant value, i.e. 21, and the second column one of decreasing integers starting positive and then going negative. We then locate the positive constant value and its negative equal, highlighted yellow. Applying steps 1 and 2, we obtain the values shown, and regression analysis gives the identities shown, which, because y becomes negative, gives us x cubed minus y cubed all divided by x minus y, even though the regression equation is unchanged. The mathematics we have derived is shown on this slide, the resulting equations being called the binomial numbers. See Wolfram MathWorld for more on binomial numbers. This slide and the next one show the two parabolas obtained by the two equations and are identical for the shape and the values of the numbers they contain, and only vary with regard to the position of the axis of symmetry, which is in the positive quadrant for this slide and in the negative quadrant on the next slide. Finally, Like a Houdini endlessly pulling rabbits from an empty hat, I am at last a truly remarkable mathematician. Yuck.